that we will continue to do as we have done in the past. And this is slightly different. What we are doing here is a recap of AWS 2019 reInvent. I'm sure a lot of us know reInvent, and probably a lot of us have also had the opportunity to attend. But reInvent is AWS annually event in Las Vegas, where they introduce all the new features and services and ideas that they are trying to, to bring to the market, and to just go over their technology and help us give us the people that are involved in using AWS. They give us an understanding of what their vision is for the coming year, and so on and so forth. So we want to do a recap of that, of the 2019 reInvent, and we'll continue to do recaps of all the other reInvents that come. This is coming late because this is the first, and we thought it would be a good idea to do it anyways, and so that going forward we'll also continue to do other recap sessions. We have two people that will be two very prominent AWS technologists in our midst that will be helping us with this section. And we also have another session that will be carrying on, that will be going on next week to go over some other technologies as well. So please watch out for that, and we hope to have as many of us that are here join us for those sessions as well. But briefly, just to go over what the community is. So this is AWS Nigeria user group. We're basically a community of AWS engineers or enthusiasts, people that want to know about AWS and people that are interested in cloud technology in general. So we are committed to promoting the adoption of AWS cloud technology in Nigeria and in Africa eventually. We have different partnerships with different groups in Africa and in Nigeria, and we hope to continue to push the adoption as much as we can. We also want to help build networks amongst ourselves, share ideas, disseminate knowledge around AWS cloud technology. For those of us that are part of the WhatsApp group or the Slack channels, I'm sure you have engaged in different kinds of conversations around AWS, and there's people connecting with other people, and we want to continue to do this more. And so thank you again for being a part of this community. And if you're not a part of this community yet, you're always welcome. Just feel free to reach out to any of the organizers, and we'll talk to you about how you can join on the WhatsApp or Slack or any other channels that we have. So brief introduction about our presenters today. They are all going to introduce themselves in more details when the time comes, but I will do a short introduction here. So we have Olawale Olaleye, who is the head IT and security at Carbon, and he will be talking to us today about Amazon Code Guru. I will let him go into details about what Amazon Code Guru is and all that good stuff. We also have Ewere Diagboya, who is a cloud evangelist, and he's an AWS community hero. He will be talking to us today about Fargate and Kubernetes. I'll let him go into details about what these technologies are during their presentation. Just a quick, overview of what the format will be like. We are Olawale is going to talk about Amazon Code Guru for approximately 35 minutes, and then we'll have Ewere to talk about Fargate Kubernetes, and then we'll have a Q&A session at the end of it. We have an opportunity to do a raffle, so that we have two raffles for free. We have 2 tickets for free AWS credits, approximately $25. But we'll be throwing out a poll to get answers from you. So the first 2 people that can respond based on the answers from the sessions, 1 question from each of the sessions. The first 2 people that respond will get this $25 credit on that they can apply to their AWS accounts. So if you have any questions, please feel free to reach out on the chat group. We have all paying attention. We have organizers looking at the chats, and please make sure to mute your microphone. So Olawale, please introduce yourself and talk about Amazon Code Guru. Thank you.
Okay, I forgot to check if I was muted. So my name is Olawale Olaleye. I think it's a privilege to be here to share one or two things with League of Experts like everyone here. So honestly, it's really a privilege. So I currently work with Carbon as the head of IT and security. So primarily, I'm an infrastructure and security solutions architect. So I consider myself also a DevOps advocate and also cloud advocate, basically. So hopefully we'll have fun today, fun to catch.
Sure. If you want me to stop sharing my screen, let me know, and then you can take over.
You can stop your screen. Let me share my screen.
All right, there we go.
So it says host disabled and then the sharing screen.
Okay, give me 1 second.
Cool.
Yeah, you should be able to do it now, sir.
Yeah, there we go.
Try it now. Try to share.
Okay, are you see my screen now?
Yes.
Oh, brilliant. So quickly, I don't know if you can give people room to just say one or two greetings. I'd like to just say shout out to everyone that participating today. So if you could just unmute yourself for about 10 seconds and say hi in the channel, that would be fine.
Hello, hi everyone. How are you doing?
Hi. So who wants to go next?
Hi everyone, this is Ayo from Color Gig.
Cool, Ayo. Next.
Hello everyone, this is Afolarin.
Hi.
I forgot to, my name is Adekunle. Pleased to meet everyone.
Cool. Next. Who wants to go next?
Hello, my name is Doyin Shomoyi, calling from Lagos.
Hi. Hi there. Who wants to go next?
Hello, my name is Samali from Lagos.
Okay. Cool. Next person.
Hi. Hi.
Hi.
My name is Adedayo Awayi,
Hey,
Beyond Technologies.
Next person.
Okay.
So is that all? Can I go ahead now?
Yeah, please, you can continue, Olawale.
Okay, cool. So once again, it's a pleasure to be here, and I think I'll try as much as possible to make this session interesting and interactive so that we can actually learn from each other. The presenter too can also learn from the audience. So yeah, I want to talk about Amazon Code Guru. One of the things I hope to share during this session will be one of the features, benefits of Amazon Code Guru, then how Code Guru works with a demo. We'll do, if we have enough time, we'll actually do one or two demo. Then about the kind of recommendations Code Guru also makes so you can remediate quickly. So how did it start? So 2019, remember we're doing a recap of ReInvent. So 2019, Andy Jassy unveiled Amazon Code Guru, which happened in December. The idea was that customers will be able to push code to whatever source repository they use, which is the CI stage for many of us that do DevOps. Then Code Guru will be able to pull that request, review the code, and give you recommendations. For some organizations, what they do is they leave this out to another software developer, which is called peer code review. So, but at launch preview, the service was already integrated with GitHub and. So one of the reasons why I like the idea of this session that we're having, it also gives you a press report to be able to know how it all started and where they are right now. If you know AWS so well, they're one of the few tech companies that is very committed to continuous improvement. So from that time till now, they've been able to add Bitbucket and GitHub Enterprise Server. So I, for one, I use GitHub. I use GitHub, but for production, particularly at Carbon, we use Bitbucket. So when they announced Bitbucket, I was so excited. So what was Code Guru? I was trying to figure out where they got the name from. So we're all familiar with. Can every other person mute, please? Just go mute. Thanks. So, who is a guru? A guru is basically someone that gives advice, happens to be an expert in that field. So, in my thinking, I was like, oh, this is where they got the name from. So, which kind of makes sense. I mean, I've seen a lot of arguments online that AWS are actually not so attentive to naming their products, but this is a win in terms of how they name the service. So someone who gives you advice on how to do things better, you can consider that person a guru in that field. So which makes sense. Let's go next. So what is Code Guru? If you're in this session and you haven't really tried your hands on it, or maybe you haven't even heard of it before, so it's actually a developer tool, which is powered by machine learning. Yeah, machine learning has been changing the way we do things. We've seen a lot of adoption of machine learning, even in cloud. And Amazon has been using it to drive their services. So it's a machine learning tool that helps you to do code assessments, automate your code reviews, and gives you performance recommendations. And another machine learning driven service on AWS is Macy, which is actually for security analysts or people doing security. So Code Guru has two components. The first one is profiler, and the second one is reviewer. We'll get to that in the next slide. The Code Guru reviewer helps you to do automated review. Let's say you are trying to be agile and you want to take away the process of doing code review. If deliver fast really matters in your environment or your organization, then you should be looking at Code Guru. It helps you automate how you do code review because, and how does it work? Even though we get to that part where we talk about how it works extensively, It uses, all machine learning, they use models, they train those models and keep improving as it goes. So that's how this reviewer came about. So primarily it's based on how Amazon in itself as a company has been doing reviews. So they took that knowledge, brought it out, used it to create a service which you can actually adopt to your own environment. The second one is Code Guru Profiler. This tilts towards people doing DevOps and infrastructure mostly. If you ever had one or two arguments with a developer, that's if you are on the infrastructure side, whereby the developer comes to you and say, oh, my code is not running. It was running when we first did the first release. Now that we added new services, it's no longer running. It's because of several challenges may creep in. So one of them is optimizing the resources that the code is actually consuming. So this particular component of Code Guru helps you to identify the pain points in your code, help you to know the code that is consuming most of your CPU and your memory resources. So in turn, it saves you money. It helps you save infrastructure and operational costs. So how does Code Guru Reviewer works? Like I said, it helps you to analyze code, automate code review process. So from the time when you push your code to the repo, and you create a pull request. So it extracts some semantics and patterns from the code that you pushed. So then those features and patterns are compared against machine learning algorithms. Then it does its normal stuff by trying to compare against previous patterns, and it does some basic checks. We'll talk about those checks in the next slide. So after that, it makes recommendation. If there are no recommendation, fine. That means you guys are okay. And whoever wrote it is probably a badass software engineer. So Code Guru Reviewer kind of recommendation. So if you're using Code Reviewer, what are the kinds of recommendations you get? Remember I said is based off Amazon's internal knowledge, their process, their standards, their procedure, and their approach to software development, particularly coding principles. So they compare it, they make those recommendations from their own AWS best practices. And trust me, if you run a tech stack and you are maybe you're using AWS cloud and you're following AWS best practice, you're on the right track. Hardly will you run into issues. So for me as a person, most of the thing I do, I tailor it towards AWS best practice. Of course, I had some other stuff to it, like because I'm security oriented as well. But with AWS best practices, you're probably on the right journey. It also gives you recommendation based on concurrency, resource leaks prevention, sensitive information leak like credentials management, and then it gives you common coding best practices. Those common ones are what they pull from open source projects. It talks about refactoring, gives you recommendation on input validation as well. So let's now look at Code Guru Profiler. Like I said, there are two different components. So Code Guru Profiler itself has three resources with which it works as well. It has an agent, it has profiler service, then it also gives you agent recommendation. I know many people are very familiar with CloudWatch agents. So you know how maybe you want to pull logs and performance metrics that the normal AWS service doesn't give to you, and you want to do your own custom metrics. You can use CloudWatch agents, install it on the EC2 instance, then stream it to CloudWatch log. That's how the agents work in this regard as well. So you can start the agent using code. You can refactor your code to start the agent, or you can use Java command line to also run the agents. So the agent run as an in process as part of your app. how you have your Java project running in Tomcat, that's how it runs as well. So it gather metrics, send those metrics like every 10 minutes, send it to your profiler service. Then your profiler service, it does the aggregation. It collates all those data, use it to make, in a way, in a format and structure where you can get an intelligence recommendations from it. So you publish that data in interactive flame graph. Is that graph that you can now visualize. And one of the things that AWS did with this service was that they brought in visualization. I don't know, I've gotten a lot of feedback where people say, you just have to be a proper engineer to use AWS Cloud. But for this one, they tried as much as possible to make sure that the feedback is interactive enough and is well constructed in a way that you can visualize it. So then after the profiler service publish the data, then you get your recommendations from it. Then it also gives you alerts, continuous alert based on those recommendations. So what are the types of application you can profile with this code profiler? You can, for now, Code Guru works with just Java. So if you're thinking of Node.js, if you're thinking of Python, you should be looking at another solution. But you know, AWS, they are very committed. I won't be shocked if they release something. I'm actually keen and waiting for JavaScript as well, because we have a lot of that in our code base. So Code Guru Profiler works with application that you host on EC2. Remember, Profiler gives you infrastructure consumption analysis of your code that is running. So you should be thinking compute in this regard. That's what you should be thinking. So that when you think of Profiler, think of compute. How you, my friend Ewere used to talk about saving costs. I used to see his post on saving compute costs. So these two also help you to move towards that direction where you don't just over provision resources because, it's a Java app. And we all know how Java app can be. I think last week I was having a wonderful conversation with one of our engineers where he had to go and provision a 32 gig RAM compute because he said it was Java. I was saying, Mr. Man, you start from the barest minimum. So then what are the things you've put in place to properly track the infrastructure cost of the code that you're deploying? So this is Profiler. This is what Profiler does. It works well with your app on EC2 for ECS and EKS that the next speaker will be talking about. Then it also works for serverless as well, whether you are doing serverless container or serverless. So if you've not heard of serverless container, watch out for the next session. So Amazon Code Group of Profiler currently supports JVM applications, including Java, Scala, Kotlin. That's if you are doing mobile apps. So what's the challenge for everybody? Code quality challenge is a challenge for everybody. It's not just for developers. It's for the guys that provision infrastructure. It's for also product managers. There's no product manager that wants to see a product released, and when they want to maintain that product, then the developers come back and start giving excuses. So it's a challenge across board. There's difficulty, and on some of the examples, the difficulty in detecting some types of code issues that human being cannot detect, no matter how, except if you want to do code review for 3 weeks. Even at that, it can just be too difficult. I've seen engineers complain about this, and internally on our side, based on my own environment, we've been putting tools and processes in place where we automate those code review process. At some point, we had to even write some bash script, blah, 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 to do some of this stuff. And we're combining tools, but thankfully for Code Guru, it helps take away that human pain, what human being cannot actually detect. machine learning has been helpful in this regard. So challenges in identifying most resources intensive code methods without needing performance engineering expertise. This is where I said it saves you operational costs. For companies where they will have to go and get SREs, like 3 of them, and be paying them. If you can use 2, of course. I'm not saying sack the 3 SREs. You can keep 1, then use Code Guru Profiler to replace those 2. So you save operational overhead, right? So it helps you do catch code issues faster than what a human being can help you achieve. So the code issues that Code Guru helps you to detect, like when you're using, when you're exposing sensitive data, thread safety issues, Java is prone to this, resource leaks, then deviation from AWS principles, right? They are best practices, because particularly if you are writing Java functions on Lambda, and you're using Java SDKs and APIs, I would suggest and highly recommend AWS Code Guru, because it helps you to detect those improper use of Amazon SDKs in your code. So I think we can do a quick lab right now. I just want to show you Code Guru. So give me a minute. I think I need to confirm if you can see my next screen. Can you see my screen still? I have code open and also
Yes,
Chrome.
we can.
Cool. Okay.
Yes, we can see your screen.
Yes, we can.
Thank you. Cool. So Code Guru in itself is one of those simple, is one of the very few simple services available on AWS. You know, if you use AWS a lot, you know that you have to you have to know what you're doing. But this is pretty much straightforward. So we'll put as long as we can. I have my timer running, but I just want us to look at Code Guru now. So in my own personal environment, I use Code Guru for a project that is already running. But let's try and create a new one. Now, I don't want to reinvent anything. I will walk you through this code as well. But let's just act as if we are creating a new project from the scratch. Right. First thing is there's a sample project available on Amazon Sample Lab. So I want to fork that project to GitHub. Just hold on. Okay, this is it. So first thing, let me get this and pull it to my own environment. All right, we are here. In case you want to follow along when you're at home, I will drop my my slide and also put the Git repo link there. So first I want to clone this guy. So this is a sample Java application. There's no two stories behind it. So I'm going to CD into it. Right. So let me create a branch from it. So what do you now do? Meetup, right? Let me use something else. Okay, we are here. So let me just try and play around with. Before I do this, I think the first step you need to do is come to code reviewer. Let me go back to the dashboard. Okay, so I have some sample project, but that's fine. So you want to associate a new repo, click on associate repo, connect to GitHub. They started with GitHub and code commit. So for now, my code sits in GitHub. So click on connect to GitHub. Then we're looking for the project that we actually recently forked, which is called Amazon this guy, right? Associate it. So it's associating. It shouldn't take too long anyway. So why that one is going on, so I just want to play with some of the applications here. Right. Let's see what you have here. Okay. Let me check what's going on here. Okay, it's associated. So let's just try and create a sample commit. Let's trigger something so that will clone. So if you do this git status, notice that I've changed the new. So this is the normal stuff we do now, like making changes to code, pulling and pushing. Okay, how to set up stream. Okay, so the developer has pushed a code, right? And we refresh. So we have two branches. This is our own branch. Right. What do we do? So as a recent push less than a minute ago. So let's create pull requests from that branch. We want our web, blah, blah, blah. So I'm pushing from this branch to this branch. So this is what I added a new note. Right? If you, before I click that, let's look at code reviews. There's no code review yet for that particular repo. This is from the ones I have already. So let's click on create pull requests. So now code review will kickstart its own work. So code review doing his own review. That normal peer developer would have done. So you're leaving it to code review to do that. Still going. I thought you said we have a DJ. A DJ would have made sense now. Just play some music in the background.
Yeah, so that's Wally, but he came a little bit late. Wally, we're just talking about you earlier. If you're around, you'd have helped us with some good music.
So while this is ongoing, one of the things that AWS is actually doing is that they are still, is a machine learning driven project. So they are still thriving on people's feedback. When this service do code review for you, you have a channel where you can actually pass feedback based on that feedback that they give to you. If you are pleased with the review, you give it a thumbs up, or you can make additional comments. So they use that feedback to still keep on training the model. I actually believe they should give this service out for free. But I don't know why they didn't do that. Anyway, they have their business model. So let's refresh this. It's still pending. That coach that much. So let me look at this one. Let's see what the issue is with this. You can see list of recommendations in this. It will tell you, then you ask you, was this helpful? If you want to correct this recommendation, just click on the link. We also have link pointers where you can read and go through the issues in your code. Oh, this is still pending. Let's leave it there for now. So while we're waiting for that, let's look at code profiling groups as well, profiler. So for example, let's say you have an application, a Java application running on EC2. This is just an installation, Java installation file, then a sample Java project. All you need to do with Code Guru is create your profiler group here. Then you structure if you want to use in code there's a widget on how to do that. But the one I prefer is using Java command, because I can pass this in my code build. I use it a lot with code build. Then it runs the agents automatically. So all you just create this bash script, because it has to run continuously. You can use cron job to run it. Then change your profiler group here. It's as simple. It's very straightforward. Create a profiling group, give it a name. Once you create the name, choose the platform. Is other platform. I'm not doing Lambda since it's EC2. Then grant it permission. Come here, create it, then run your bash script. So I also push this script in the Git repo as well. So if anybody wants to use and make sense out of it. Let's check this if it's still pending. Wow. Okay, why this is still in pending? Let's look at this one that we're looking at. Code reviews. For that guy. You know why it's taking so long. Well, it's expected. Anyway. So if you want to look at this particular code, it will link you directly to GitHub, and you'll see the issue there. You will see the code there. So let's go back to the pull request we did. About 8 comments. Yeah, so this is Code Guru work. Recommendation generated by Code Guru. Can you guys see this?
Yes.
My time is almost up. So these are Code Guru's action, giving you recommendation. Then you can pass your own feedback. You can type your feedback here. You can comment, just like how you collaborate within your team. So basically, that's all. What next do I have? I would have actually loved to demo the code profiler, but there's really nothing much in Code Profiler. So thanks for listening.
Well, thank you very much, Olawale, for that. That was really very insightful. So feel free to share the GitHub repo and all the other stuff that you use. I'm sure people would love to test it on their own as well. If there are any questions, I think we can questions at the end of the session. So just so we can get going with the next presentation, and we'll ask our questions then. So please, if you have any questions, feel free to send it in the chat. If not, we'll open the page for questions as well at the end. Thank you. The next presentation we will have is on Fargate Kubernetes, and Ewere will be discussing that. Ewere, please share your screen, introduce yourself, and carry on. Ewere, if you're still with us, your mic might be muted.
Yeah, I'm here. Hi, everyone.
Hi.
Okay, thank you very much for this rare privilege. Thanks to my humble and bosom friend Olawale for that powerful rendition about Code Guru. Today I'll be talking about Fargate basically. So I will be sharing a short presentation, and after then I will do a demonstration. Okay, can you confirm you can see my screen?
Yes, I can.
All right. So this was an introduction to EKS Fargate. But before then, I will talk a little bit about Amazon EKS. So what is Amazon EKS? Amazon EKS is a fully managed control plane from Amazon. Okay. It takes away the stress of you worrying about managing, securing, and scaling the control plane on your own. Now, Amazon manages the components of the master node, which contains etcd, control plane, scheduler, and the API server. It also saves time to set up and scale the control plane, and also to design high availability. So the control plane we are talking about here is practically Kubernetes, okay? It's a fully managed Kubernetes service from Amazon. So normally a Kubernetes basically is just a service that makes it possible for you to deploy and scale applications, okay, fast. That's what Kubernetes service does actually. So I might not be able to go deeper into that, but for basic understanding, just take Kubernetes as a service, okay, that makes it easy for you to deploy and scale applications at, let me use that word, neck-breaking speed. So before Kubernetes, you need to understand a lot of things about scaling applications, failure, disaster recovery, and all that. But Kubernetes is an open source solution that has made that much easier, much faster, and much more flexible than it used to be. But what Amazon has done is that when you want to manage Kubernetes on your own, it takes a lot of time for you to understand every single component of Kubernetes. That's one. Two, you have to be a very good expert in Linux operating system and a lot of other components for you to set it up yourself, which can take, trust me, days or weeks or even months if you're lucky enough. But what Amazon has done with EKS is they made it much easier. With the click of a button, you can get an EKS and a Kubernetes cluster ready to run and for you to deploy your applications. So that's what basically EKS is about. So Amazon automatically sets up the control plane and share the URL for you so that you can manage your cluster yourself. So you don't have to worry about how to set it up and all those things. And they use what we call the kubeconfig, which is the authorization layer for Kubernetes. And it's also tied to what you call the AWS IAM, which is an acronym for Identity and Access Manager, and helps to authorize and authenticate access to the Kubernetes cluster, where you can perform your Kubernetes operations for managing, deploying, scaling your applications within Kubernetes. So we're not here to talk about Kubernetes per se, but what we are talking about comes from Kubernetes. And here we are going to talk about Fargate. What is Fargate? Fargate is a serverless solution on Kubernetes. Now, when I was talking about Kubernetes, there's something I didn't mention. Your Kubernetes cluster comes with what we call nodes, or what we call worker nodes. Your worker nodes are basically virtual machines or EC2 instances, okay? You have a set of virtual machines that you have to manage. So even if AWS manages what you call the control plane, which is the main part of Kubernetes, there are other components of Kubernetes you have to manage yourself. Things around the virtual machines that run behind your Kubernetes cluster. So what Amazon is doing for you is to manage the control plane while you are in charge of managing the EC2 instances, which serves as the worker nodes, and which is actually where your applications get deployed into. Now, in reInvent 2019, Amazon said, okay, we are one of the pioneers of serverless in the world, okay? We are the pioneers of serverless, and we're pioneers of serverless machine learning technologies in the world. We want to take our serverless ideas, okay? Apart from Lambda, apart from Code, which Wale already talked about, that you don't have to worry yourself about having to set up stuff or the operational expense that goes with managing EC2 instances, because you have to secure them, you have to ensure that they are always up to date, you have to ensure that all security patches are up to date, and all those headaches that have to go with it. Let's take that stress away from the user and handle that on our own, while we give them a solution that makes it easy for them to run the applications on still the same Kubernetes, but without having to manage these worker nodes. And then Fargate was born. Now, before Fargate came to EKS in Kubernetes, Fargate was already on ECS. Okay, ECS is another form of containerization service by Amazon, which has always been there. But Fargate used to be on ECS, and we always wanted Fargate to be on EKS. And I mean, voila, 2019 reInvent, it was actually launched and announced, and it was generally available. Now, Fargate enables you to run Kubernetes pods without EC2 instance as worker nodes. So you don't have to worry about how many EC2 instances do I have in my EKS cluster? 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, your EKS cluster also comes with auto-scaling for those worker nodes. So it means you have to manage the EC instances, you have to configure the instances properly, you have to secure them, you have to scale them, you have to work with your auto-scaling configuration to ensure, which was a lot of overhead that you have to do before Fargate came into play. Now, it provides a new scheduler, which is called the Fargate scheduler, that provisions pods in a serverless nature. So no need to manage worker nodes anymore. Now, though Fargate has certain limitations, but it can be used to run most stateless API application workloads. Now, Fargate was just announced, okay? So we don't expect it to be in top notch at this point, but it can be used to run your basic API applications. So if you write API applications in Node.js, Python, Java, C#, whatever programming language, because they are all in containers, so basically it should be able to run it. But there are certain things it might not be able to do. One of the things it cannot do for at the moment, which is a feature of Kubernetes natively, is what we call stateful sets. So Fargate at the moment cannot do stateful sets, okay? But for EC2 worker nodes, they can do stateful sets. So because Fargate just started, I'm sure that's why you have that, okay? I'm sure that's why you have that particular feature. Can you see my screen? Please, can you confirm you can see my screen?
Yes, we can see your screen.
Okay. Please, Larry, I think everyone can see my screen. Is anyone? Okay. All right. So, thank you for that confirmation. So, like I said, Fargate has certain limitations, but it can actually be used for stateless applications. So, one of the limitations I mentioned was just stateful set. There's also another feature we call the daemon set on Kubernetes. I may not have much time to talk about this particular feature. These are peculiar features that comes in Kubernetes. They are not with Fargate at the moment. So, but if you want to deploy any kind of basic application, an API stateless application, Fargate can be your guy at that particular point in time. So I'm sure with time, Fargate is going to start being able to do things around stateful sets and daemon sets. So there's also a last thing I would like to also talk about, what I call the hybrid serverless setup. To fully maximize EKS, a hybrid architecture of using Fargate and worker nodes can be deployed. Now, the EC2 instances serving as worker nodes will be used to cover up for limitations of Fargate, okay, such as jobs, stateful sets, daemon sets, and so on and so forth. Now, this architecture reduces the operational expense involved in managing all your worker nodes as EC2 instances. So one of my recommendations for people using Kubernetes on AWS, most especially you are using EKS, is why not take the values of both environments, okay? You have been working with EC2 with worker nodes, beautiful. But you see, you can see that you are struggling with having to manage those worker nodes, okay? Once in a while, you have to terminate and shut down. You have to manage memory and CPU issues. You have to make upgrades. You have to. Why not migrate those applications you have into Fargate? So you know that operational expense of that is cut down short. It doesn't just cut down your operational expense, it also cuts down some form of capital expense because your EC2 instances have costs that goes with them, okay? And Wale was also talking about over-provisioning when he talked about provisioning a 32 gig memory machine for a Java application, just because it's a Java application. There's an assumption that it's going to take all the memory at the same time. Now, why not start with Fargate that has, say, a maximum of 32 gig memory and which scales automatically, okay? That's another thing about Fargate that you don't get in EKS, in worker nodes so easily. For you to scale up your worker nodes in EKS, it's actually a lot of work, okay? It's doable, but it's a lot of work. But if you do Fargate, it actually scales automatically. You don't have to do anything, you don't have to configure anything. If you need more memory, it provides it for you. And then if your workload also drops, Fargate also drops the memory allocated to that particular pod. So these are a lot of the advantages that you can get from Fargate. And with the hybrid architecture, you can cut down your OPEX by 50 to 40 or 60%, depending on how your workload are divided, and just dedicate those unique features of Kubernetes to your worker nodes so that maybe applications stay in Fargate, while jobs and the stateful sets all stay in the worker nodes. So give and take, what you might eventually have is you might just have just one single worker node for your applications, and then the rest pods or the rest applications are deployed in your Fargate profiles. So that's all for now. I just want to do a simple demo on the Fargate deployment, and then we'll be done. So because of the time it takes to set up an EKS cluster, I already have an EKS cluster running right here. So I don't want to bore us with the time it takes to set up an EKS cluster. It practically takes about 20 to 25 minutes to set up an EKS cluster. So I already have one here in my console, which I've already set up. At the moment, I am going to check for the worker nodes. If I have any existing, I don't think I have any at the moment. I practically had to, terminate all the worker nodes so that we can be sure that there's no escape pod running in any of the worker nodes. So if you come to the EKS console, I just opened the EKS cluster we are running, and we can see the cluster status is active. We can see all the information about this cluster. Now, for us to create Fargate, we call it a Fargate profile. We go straight to the compute, okay? And this is where we can create our Fargate profile. So I'm going to quickly open the EC2 console so that we can see that there's actually no worker node running. The only EC2 instance you are going to find here is the instance that contains the instance where I'm going to be managing the cluster from. So it's not really a worker node for the EC2 instance. So this is the name of my instance, and this is the instance ID. and it's just a Linux machine. It's a TP medium Linux machine. It is not a worker node EKS cluster. I practically terminated all the worker nodes. So what it means is that at this moment, if I try to deploy a pod, that pod is going to fail because there is no worker node. But hey, there is Fargate profile. So let's try it out and see. Now, one rule we need to know about Fargate profiles is they work with what we call namespaces. Now, namespaces in Kubernetes is used to create a layer of separation between different workloads. Basically, if you have staging, production, and development environment in what you are working on, and you want to separate them clearly, okay, without them, you use namespaces in Kubernetes. So borrowing that concept from Kubernetes, you can create a namespace and you attach your Fargate profile to that namespace. What that means is any pod or any application you deploy within that namespace is going to be deployed into a Fargate profile. Let me go over that again. Namespaces are a technique or a feature within Kubernetes for creating unique separate layers between environments, your staging, your production, or your test environments. Now, borrowing that concept, you can create a namespace and attach that namespace to a Fargate profile. What that means is if you deploy an application or a pod within that namespace, is going to deploy it into that Fargate profile. So in a case where you have a hybrid architecture of EC2 instance and a Fargate profile, with namespaces, you can separate them very clearly in the sense that any pod on an application or any container you deploy into the Fargate profile or that particular namespace will ensure that that is deployed in that Fargate profile. So I'm going to demo that right away. So the first thing I want to do is to create my namespace in my Kubernetes cluster. I will manage it from my command line interface, which I will be sharing right away. Okay, I just need to confirm that you can see my terminal. Can you see my terminal?
Yes, we can see it.
All right, so I already have a Kubernetes cluster running, and the first thing I'm going to do is I am going to create a namespace, okay? So to create a namespace, I'm going to use the kubectl command, create namespace. I'm going to call it AWS Nigeria User Group demo. Okay, it tells me the namespace has been created. So we're going to take note of this namespace and use that when we are creating our Fargate profile. So I'll copy this out because I'm going to use it very soon. If I want to confirm that the namespace is created, I can do a kubectl get namespaces. And I can see it's actually created and it's active for 23 seconds. The next thing I want to do is to create the Fargate profile from my console. Please take note, I'm trying to go through this approach. There are other ways you can do this. If you already have your system planned before time, you can actually create your Fargate profile as you are creating the cluster for the first time, okay? This is an architecture for when you already have an EKS cluster running with worker nodes, and it's like a production setup. You cannot terminate that cluster to create a new one. So you want to attach Fargate profile to that particular cluster so you can do the kind of setup. So my assumption here is I already have this cluster running. I don't want to touch it. I just want to attach Fargate profile to it. That's why I have this. So take note of that. It can be for a fresh setup, okay, but this is for already running production workload. So you don't have to tamper with your production workload or terminate that cluster because you want to add Fargate profile. There's also something else I didn't mention. Fargate profile works from Kubernetes 1.15 and above. So you need to take note of that. Your Kubernetes version you're running on EKS matters a lot. At the moment, I'm running 1.16. That's why it's enabled. And I'm already told to upgrade to 1.17, but I'm not going to do that right now because it takes a lot of time to do that. But just know that the version of EKS you are running and the version of Kubernetes you are running on EKS determines if you will have Fargate profile enabled. So if you open your own and you can't find it, just know it's a version you are using. So let's dive deep in and add our Fargate profile. So we're going to give our Fargate profile a name. Just to make things simple, I'm not going to use any other name. I will use the name of the namespace. But please, it doesn't really matter what you use, okay? It doesn't matter what you use. You can use any name. It doesn't matter. Where it matters is at the next stage so that you can connect the Fargate profile to the namespace. I'm going to choose an execution rule, which is the role I'm going to use to execute this, and I'm going to choose the one for this cluster. Okay, that actually is generated when I created the cluster. And I'm going to choose the subnet. Now, the rule for creating Fargate profiles is they should be in the private subnets, not on the public subnet, because they do not require public internet access. So I'm going to uncheck all the public subnets and leave just private subnets running. So I have 3 private subnets and 3 public subnets. I've unchecked the 3 public and just left only the privates. This is just tagging if I want to label it, but I don't want to do that right now. So let's go forward to the next stage. Now, this is where it's very important. You can see it's called pod selectors. These properties cannot be changed after the profile is created. So add a namespace to select pods from. You can see the message is very clear there. So I'm going to simply paste the namespace we already created. Okay? When I paste that, that's the first layer at which it will make sure that any pod I deploy will go into that namespace automatically into the Fargate profile. There are other conditions I can add around label, okay? Add label to specify which pods for this namespace to run on Fargate profile, but I don't want to do that, okay? But it's also a very important feature when you want to increase the level of granularity to how you specify where the pods must be deployed into, okay? So, but I don't want to do that. I'm okay with namespace. I'll just move on. This is also if I want to add a namespace, and I want to add for another namespace. Well, I don't want to do that right now. Let's just keep it simple and move on. So we're done with all the basic configurations. We just verified everything we have configured here, and when we are okay, we click create. So typically it takes roughly 5 minutes, for this to come up. So maybe to give us some time to ask some questions while this comes up. Then when it comes up, we can just finish up about which will be just deploying a pod, and I will show you that it's actually within that Fargate profile. And I'll go to the console to show you that there's no EC2 instance running. So you don't think that there's an EC2 instance running and I've deployed and it's showing the EC2 instance. All right, thank you very much.
Thank you, Ewere.
This is going to take a while. So I think it's some questions while this is actually still running.
Thank you. So while we are waiting, do you mind going over some basics of Kubernetes? Maybe just talk about what pods are and some other concepts that we can just for those of us that have not used Kubernetes before.
Okay, Kubernetes is becoming an ecosystem as I speak. And one of the things we need to know about Kubernetes is there's a high chance Kubernetes will replace your native Linux, okay? So if you want to deploy applications moving into the future, nobody might want to know if you have any Linux experience. People just want to know if you know how to build Kubernetes and you know how to manage a Kubernetes cluster. Why? The reason is Kubernetes has been able to make application deployment and scaling much easier, much faster, and less stressful. Now, how has it done that? It has used the concept of distributed computing to do that. Now, the concept of distributed computing is where you do not actually have to you distribute a particular service or a particular application. Now, what we are used to is if you want to deploy an application, you get one server, okay? You put the application in that server and you are okay. When you have more users, you do either what we call horizontal or vertical scaling, adding more servers, okay, or increasing the resource of the current running server. That's the basic way we do that. But there's also the part of management. There is the networking part management. There's the management of each of those applications on each of those servers, which a lot of people have used things like Puppet and Chef to solve over the years. But there is still a challenge because, I mean, those people who know how to do Puppet and Chef, you know what it is to do Puppet and Chef. You need to have a PhD in configuration management. It's a lot of management. It's a lot of management. So Kubernetes came into play and solving that problem because Google has been using it for quite a number of time and it was open sourced. So since it was open sourced, other people have been able to take it, and just like Amazon also took and created EKS out of it. Now, what is the pod? When you write your application and you want to deploy in Kubernetes, Kubernetes it's not tied to a particular language where you say, because it's Java, it doesn't work in Kubernetes. No, you encapsulate your application into what we call a Docker container. Now, when you put your application in the Docker container, that application can run in any Linux operating system. Kubernetes also being part of the environment, it can run. So when you put your application in the Docker container, like we call it Dockerization, to Dockerize your application, you can deploy that application in Kubernetes. When you deploy that in Kubernetes, Kubernetes no longer sees your application as a Java application, as a Node application. It sees it as what we call a pod. Okay, it sees it as a pod, and that's how it's able to manage and ensure that the application is currently running. One very beautiful feature about Kubernetes that I'm going to say here that is very, very interesting is it has what we call self-healing. What's self-healing? If your application fails for any reason, or it goes down for any reason, I don't want to know what the reason is. It's a bug, you don't have enough resources in your machine, Kubernetes will automatically recover that application for you without any manual intervention. Okay? That is one of the biggest value Kubernetes brings to the table that you usually don't get in any other system you are trying to use. There are other parts of Kubernetes that I might not be able to exhaust. I mean, it's a whole ecosystem. The other thing we also have in Kubernetes is what we call the service. The service is practically where the service is practically where you receive network requests into before it gets into the application, okay? And I also talked about namespaces, okay? So instead of you to create different servers, one for staging, one for production, one for test, one for this, no. You can have a single Kubernetes cluster that will handle staging, production, and tests at the same time. What you need to do is to create a namespace for staging, create a namespace for production, and create a namespace for tests. And ensure that you deploy your application in those specific namespaces. So you don't have to worry about managing different servers for your application. Okay, I think the profile is up. I'm going to share my screen right now.
Good. Thank you for that, for the answers.
Please just confirm you can see my screen.
Yes.
Right, thank you. So if you look very well, you can see that the status is actually active right now. You can see the namespace we selected and the name of the Fargate profile. Please, profile name and the namespace name must not be the same. Please. I just did it for the sake of this demo so that we can quickly move forward. You can use a better name so that you can quickly identify it. But the namespace you created in Kubernetes must be the same namespace you are attaching to the Fargate profile. If not, your deployment will not get into the Fargate profile. So I have a simple deployment I want to quickly do. Sorry. Okay, so I'm going to be performing a very simple deployment of an Nginx application. Okay, so this command is supposed to deploy an Nginx image into this cluster, and I'm using the namespace for what we just created right now that is attached to that Fargate profile. Now, mark you need to ensure that you attach that namespace and equal it to the namespace you already created, which is attached to the Fargate profile. So I said kubectl create a deployment. A deployment is what you use to house a pod. Okay, like I said, a pod is like an application deployed in Kubernetes. In this example, my application is an Nginx application, okay? And the version is 1.14.2. That's a Docker image actually. And I want it to be deployed into the namespace called AWS Nigeria User Group Demo. So when I'm done with my command, I hit the enter key. And if you look at the message here, it tells you that this is already created. Now, how do we validate that this is actually working? We are going to check if the pod is running. So the command that is kubectl get pods, and we need to specify the namespace. There are various namespaces within this cluster. So specifying the particular namespace we want to target is quite important. If not, we are going to be checking another namespace. So, sorry, I think there was a typo error there. Yeah. So if you look at it, it's still saying pending. So give it a while. But the way you will be sure that this is actually running in the place it should run is when we check the, okay, it's running right now. So you can see it's actually running, status is running, 1 of 1. Now, how do we confirm that this is actually true? The first thing I will do is I will go back to EC2 instance, and I'm going to refresh this page so that you can see that it's still the same EC2 instance that I had that was running, which is actually this one I'm working with, okay? We can confirm that with the IP address. You can see the IP is 212.37, which is 212.37. I'm going to refer you to know that there's no EC2 instance running somewhere that is hidden. That you think maybe I hid one EC2 instance somewhere and I'm trying to play a trick. There's no trick here. We're in the same region. You can see the page has reloaded and it's the same EC2 instance. So there's no other worker node. There's no EC2 instance. But how do we validate what I'm saying? If I do kubectl get nodes, nodes are the EC2 instances that run within your Kubernetes cluster. It's going to show me one worker node, which is the Fargate profile worker node, which is actually serverless. So it's not here. If I come here, it's not a server, it's the Fargate profile running here. So there's no EC2 instance, there's no VM, there's no server, it's serverless, basically. So I don't have to worry about how to monitor the CPU, the memory, or if I need to manage anything. I just manage my applications and all. The last way to validate that this pod is actually running within this Fargate profile is to use what we call the describe command. Now, a describe command in Kubernetes tells you where a pod is running within that cluster, which particular place it is deployed. So I'm going to run that command right away, and that will be all. So kubectl describe pod. I'm going to describe this pod here. Don't forget your namespace, very important. You don't specify a namespace, you are going to be checking another namespace, which could be a big problem for you. So I need to specify the namespace again. Demo. Now it's going to bring out a bunch of information, but don't worry. we'll simply go up and check the particular pod that we have labeled here. Sorry, something wrong there. Okay. Ooh, my terminal is acting funny. Sorry. Showing the wrong messages. Okay, so if you check what we call the node, which I'm highlighting right away, you can see it's actually the Fargate node that it's deployed it into. So this has proven that this pod is actually deployed in the Fargate profile, not an EC2 instance, not a virtual machine, but a serverless environment. And lastly, the scheduler, okay, which is what actually deploys or determines where your pod is going to be deployed. It's a unique scheduler called the Fargate scheduler. So the method and technique of working is quite different from the native Kubernetes cluster. Thank you very much.
Thank you very much, Ewere. That was very, very helpful. We will go next now to the question and answers. Please, if you have any questions, feel free to send it into the chat. I would open the channel now, and we can have, if you have a question, you can also unmute your mic briefly and ask the question. Let me share my screen real quick. Yeah, so this is question and answer time. I will go first, actually. I have a question. And this is a question for Olawale. For Code Guru, for Amazon Code Guru, what do you, or from your experience and your perspective, what do you see is the biggest challenge with like adopting Amazon Code Guru?
Okay. In my own experience, I think you have to be with our tech stack, right? So we don't do just Java. Java is what we use for just core backend, but we have other backend apps which are just on the fly because we do a lot of microservices and serverless computing. So most of them are usually Node and Python. So we have more of, and I think same thing applies to our companies as well. So the challenge with adoption is the fact that it just supports just Java for now. And also the fact that the second thing is because I've seen some recommendations that my developers don't actually agree with. So when you are adopting, I would say you should have a flexible mind, particularly if your organization, you adopt strict compliance. The two parts have to be flexible to take feedback from the developers. You remember that the tool is actually for the developers. And since if you are operating a DevOps principle, that shouldn't even be a problem. So you can create your own custom rules outside the recommended principles or the recommendations that were given to you. So those two challenges, the fact that the models are still in trade, is still at the early stage of release. So that's it for me.
Yeah, thank you. Thank you very much for that. The floor is open, guys. If you have any question, please feel free to unmute your mic and ask your question. I'll leave this open for 5 minutes.
I have a question for Ewere. Okay, so for the Fargate you discussed about, for someone that has not used Kubernetes before, so is this something that one can just delve into, like to start using, or one needs to first like have a background knowledge of Kubernetes before he can start using the Fargate AWS EKS that you talked about?
Okay, actually, you really need to have some background knowledge on Kubernetes. It will help a lot with the Fargate implementation. But Fargate doesn't only exist on Kubernetes, that's the advantage. So AWS has Amazon ECS, which also has Fargate. That's actually where Fargate started from. So ECS is a bit much easier, a bit much easier to onboard into than EKS. So if you want to use Fargate, you can use it on ECS also, which is Elastic Container Service. Amazon Elastic Container Service, and it also provides you the same and even better functionality than Fargate on EKS. I hope that answers your question.
Yes, it does. Thank you.
I see Ciola has a question. You can unmute your mic and ask your question.
My question is
the volume is low. Can you, address it?
Sarah is raising her hand.
Yes.
Okay. Is it better?
Yes, it's better now.
Yes, I can hear you now.
Okay. So my question is, you were saying something about subnets. I think the audio on my end trailed off. So I think you mentioned reasons for disabling public subnets and private ones. I'm not really sure, but is there any particular reason for doing that while creating the Fargate?
So AWS does not allow you to create your Fargate profile in a public subnet. I mean, one of the reasons I believe so is because you really don't need them to be on a public subnet. It's not a web server that needs access over the internet. It's something that operates within the Kubernetes cluster. Okay, it creates the IP, creates the CNN network interface within the cluster. So if you are putting it on the public subnet, most likely it's not going to work, or it's going to fail, or you're going to expose it for security vulnerability. So instead, you are enforced to create your Fargate profiles in a private subnet. So for example, you are creating it in a VPC that doesn't have a private subnet. You have to ensure you have a private subnet before you can create your Fargate profiles.
Oh, okay, that makes sense. Thank you very much for the reply.
I actually have one more question. This is for Ewere. So is Fargate EKS cheaper than EC2 EKS?
That's a very dicey question. So technically, there is always a concept that serverless technologies are cheaper, okay? But if you want to compare the cheapness on the grand scale of things, you have to measure it very fairly, and this is how. There are two things you measure in costs. We have what to call the capital expense, which is what I will call upfront costs. Okay, let me give an example. If you want to buy a shoe, what's the cost you look at? The cost of the shoe, right? Getting.
Yes.
Hello.
Yes.
Yeah, you look at the cost of the shoe, which is say $70 or 50,000 naira. That's the thing you look at. But most of the time, we don't think about transportation to where I'm going to get the shoe, transportation back, the risk of getting there and not meeting the shoe. Do you understand? Those are what I call, or what we call, operational expense, which we usually do not quantify. Most times, I mean 95% of the time. If you want to buy bread in the supermarket, what you only think about is this bread is 200 naira, and you just buy it and you come back. But you did not know that you had 1 calories to buy that bread. You went to the shop. You stood for days. As mundane and as little those things are, they are very quantifiable. You burnt energy. So same thing applies in this scenario, because when we are running any service anywhere, I don't know what the name of the environment is, there is always operational expense of employing someone to manage that server for you. That's an overhead, and you cannot quantify the work put in there, the security, the availability, the update patches. You understand? The person writing maybe Ansible script for update. You don't really quantify those things, but there is a cost that goes with that. Now, if you want to measure in that light, then serverless is always cheaper. So I can say for that, Fargate is always cheaper than EC2. Okay, but on the flip side, there is also the cost of learning curve. There is also the cost of trust. Some people will tell you, I will never use Lambda. Why? They feel that they are giving away the control of the environment to Amazon. Okay, which they feel that it's not good enough, which is also a cost for the business, because once you have trust issues, then people will not be ready to pay for that particular service. So on the flip side, I would say EC2 is cheaper, because people will definitely go for EC2 for Fargate. You understand? So it's actually an architectural decision, weighing all the possibilities, the pros and cons, before you can actually say, for us, because we use Fargate for XYZ, it's cheaper or it's more expensive than using an EC2 instance.
Yeah, thank you for that answer.
Let me add to what Ewere said just now. I think we are all professionals, so this kind of questions do come up, particularly at stakeholder level. So when you are comparing, particularly cost is a factor, you don't do head-on-head comparison. Number one, the two services don't even give you that leverage, because for Fargate, you are built by running our computes, and why EC2 is similar, but it's a bit different. So you have to look at other cost of operations, and that's what Fargate leverage on. Then I've actually tried something in my own environment whereby I was using EC2. I compared the cost with Fargate. It's relatively the same pricing. So, but Fargate was helpful at the long run when we had to scale, because it automatically takes care of the need to scale resources, since you don't even actually control it. You know how you have to think about operational head. Like if I want to delete containers that are not in use, I have to write a script on EC2 containers to do that, but Fargate handles that for you.
Okay. Last call for any questions.
Yeah, I think Larry has a question he posted on the chat. He was saying, how does the decision to use Docker for a deployment differ from Kubernetes? So, Larry, to help create some clarity, Docker and Kubernetes go together. Okay, you can't separate Kubernetes from Docker. Okay, what Kubernetes does is, sorry, I'm going to use this statement here. Docker makes Kubernetes makes Docker run on steroids, basically. So what you have to do manually, okay? What you have to do manually of ensuring that your application is at planet scale, creating 50 copies of your application so that if one goes down, the other recovers. If one goes, the other recovers. Kubernetes does that for you without little or no configuration. Once you configure it and tell Kubernetes, give me 50 copies of my Docker container, Kubernetes will automatically do that for you. Okay, so Docker and Kubernetes are actually two separate entities. Kubernetes makes your Docker application or your Docker deployment run better, okay, more efficiently, cutting you a lot of operational costs in terms of managing the application on your own and helping you ensure that the application recovers automatically and scales better. I don't know if Larry is there. Was I able to answer your question, Larry? I don't think he's here. Okay, I think he's not here.
Yeah, I think he might have dropped off. Yeah. Cool. Any other questions?
Sorry, the question I want to ask is if the link to the recording will be shared.
But yes, the link to the recording will definitely be shared. I believe you asked the question on the chat. Sorry for not replying.
Nobody responded. That was what I had to ask.
Yeah, I apologize for that. You mentioned that there was a Telegram group, so I was not sure if if it was the same group. So I was kind of like trying to understand that.
Okay.
Yeah.
Thank you.
No problem.
Okay, so my name is David. So I just have a question for Ewere.
Sure, go ahead.
Hello. Okay. Yeah. So my question is around microservices management. So say you have hundreds of services that you've built, APIs, for example, that are supposed to run on different ports. Usually, you're supposed to be accessed from different ports, and you want to manage them on the Kubernetes cluster. So my question is, how do you use a single port of entry for all those microservices? Like, how do you do a mapping for a single port of entry to be able to access all the services? I don't know if
All right. Thank you, David. If I want to reiterate your question so that we are sure, because the question can come in different angles. So you're saying that you have 100 microservices, right? And they all have unique ports they are running on, right?
Yeah.
And you want to have a single entry for all these different ports.
Exactly. Yes. Yes.
Okay, now within Kubernetes, you have what you call the Ingress Controller. Okay, the Ingress Controller creates a single entry point for each of your microservices, with all having unique ports. But the next question is, how do I now differentiate each of these services? Okay, now the Ingress Controller has a way of doing that. There are two methods of differentiating each of the services or each of these pods. You have what we call the path routing and the host routing. Path routing is, let's assume you have service A, service B, service C, okay, running on different ports. Your Ingress Controller can be, say, johnson.amazon.com, okay? That's the URL pointed to your Ingress Controller. Your Ingress Controller is usually a load balancer, okay? It could be any of the type of load balancers, the network, application, or classic load balancer, okay? Now, when a user types johnson.amazon.com, it has to do a /A to go to service A, or a /B to go to service B, or a /C to go to service C. That's what we call path routing. Now, with that path routing, each of the /A will point to service A, /B will point to service B, then /C will point to service C. You get that?
Yeah, I
get
you. Yeah, I get you.
Yeah.
I get you.
You also have what you call host routing, which means you want to use things like a subdomain. So instead of you to say /A/B/C, you can say a.johnson.cloud.com, b.johnson.cloud.com, c. So that's more of a subdomain routing. So if the user goes through that subdomain, Kubernetes will automatically route that request through the load balancer via the Ingress Controller down to that particular service that has a unique port. So all this can be configured within Kubernetes.
Okay. Yeah, I get you. Thank you very much.
Right.
All right. I think that's it for the questions and answers. Thank you, everybody that asked a question. final announcements. This is just to remind us about the next session that we'll be having. That will be next week, starting at the same time, 5 p.m., August 1st. So please feel free to join us. Again, I just saw on the chat that Larry said his question got answered. Larry, I think when your question was answered, you might have disconnected. So, Ewere, do you want to answer the question again?
Can Larry speak up, please? Let's be sure he went.
Can you?
Yeah, hi. Hi, good evening, everyone.
Yeah.
I sent the question, but I think a call came in and I got disconnected off the call, so I couldn't get the answer. So basically, my question is, I know containerization, I see similarities between KA, Kubernetes, and Docker. So choosing which of those solutions to implement whatever you want to implement, is there like a framework or an ideology you follow, or based on this, I should choose Docker to implement my application clusters, or should I follow Kubernetes? Because I know Kubernetes is a bit complex, and I think a lot of people move away from it and Dockerize their solution. So I just wanted to understand, is it because AWS doesn't really have a Dockerized kind of solution for now? Everybody's using the EKS and the Fargate you mentioned, or is there like an application specificity that makes you choose either of them? That's really all I wanted to know.
All right. Before I continue, I want to ask a little bit about your background. Are you a software engineer, first of all?
Yeah, I'm a solutions architect.
Okay. So were you a software engineer at any time? It will help me to explain what I want to say next. I'm sure you've written one
time ago, maybe just early after university, for a little while.
All right. Awesome. Now, the way you have a lot of programming language out there, okay? You have Python, you have Java, you have C#. Okay, that's how you have different kind of containerization technologies like Docker, like runkt. Okay, these are all containerization technologies. Now, the way you have operating systems where you need to run that your programming language into, that's how you have Kubernetes, where you need to run your containerized application inside of. So they are not similar. They do different things. One is for packaging the application. The other is where the application will have to run. Okay? Kubernetes is where your application runs. Docker is how you package that application. I don't know if you are getting me. So you don't choose one over the other. They go together. Are you getting me? So if you containerize your application, you have to deploy it somewhere. It has to run somewhere. And one of the best, what we call container orchestration tools out there is Kubernetes. Are you with me? Hello, Larry.
Yes, I am. I'm here. I'm still here.
So it's not a choice of whether Docker or Kubernetes. No. If you containerize your application in Docker, you have to run it in a container orchestration service. And number one in the world right now is Kubernetes. So after containerization, you have to deploy in, say, a Kubernetes. There are others out there. There's Mesos, there is Amazon ECS, okay? There is Cloud Run, and there are lots of them out there. But Kubernetes is topping the chart because it is open source and it's been used by Google for a lot of years. Almost 10, 15 years for running search engines. Google search you use right now was largely run on Kubernetes for a lot of years. So people trust it because it has been tested and has been used for production workload. And Google just open sourced it a few years ago and the world has jumped on it. Unlike other container orchestration tools, they are open source tools that have not really been tested in production workload. So hence, people have jumped on Kubernetes and it is very Linux friendly. It is quite, I think, one of the easiest to work with, and everybody's contributing to it. Hence, Kubernetes is growing at the speed as it is growing. But Docker and Kubernetes do two different things. Before you came, I was using a term. I said Kubernetes helps your containers or your Docker image to run on steroids. So what you should be doing manually, or what you cannot even do manually in terms of what you call self-healing, auto-scaling, and quick delivery of your applications manually with Docker, Kubernetes will do that for you automatically without any manual intervention. So that's what Kubernetes does for you.
Okay, it makes it clear now.
It's not compulsory to use Kubernetes. You understand me? But it is a good option. Because there's a lot of, I mean, that's the only container orchestration tool that has more information than any other container orchestration tool you want to use. Like I said, based on Docker, based on it being open source, and based on everybody contributing, there's a lot of information, a lot of documentation, a lot of, I mean, resources out there compared to almost any other container orchestration tool globally.
Right.
I'll answer the question now.
Thanks so much, man.
Sure, sorry, Sam. I don't know if I can add to what was said. Hello?
Okay, please.
Okay, so basically, Ewere has actually finished it up, but I just wanted you to know that even Docker had a solution called Docker Swarm, which was something similar to Kubernetes. And the funny thing is Docker had to leave that in preference of Kubernetes. So I think that shows you that obviously even the Docker team themselves know that Kubernetes is way better than every orchestration tool out there. Okay, thanks.
Yeah, that's very interesting.
Thank you, Adekunle, for that contribution.
Okay, so on to the next. Are there any questions? Is there anybody else that has any, I think we still can take some questions, if not. Like I said before, next week we'll have the second session. We'll also go over a couple other services. August 1st, 5 p.m. is the time when we'll start. Please join us on time. The slides and recording of this meeting today will be shared on the groups, on the Slack channel, on the WhatsApp group, and on the Meetup platform. And if you have not joined any of these groups, there is a link that was shared earlier by Akim, so you can join the Meetup, and you can, through the Meetup, you can definitely reach the organizers, and we can share the WhatsApp and Slack channels with you. Thank you very much. And thank you, everybody. Thank you to Wale. Thank you to Ewere. Thank you guys very much for the wonderful presentations you guys have done. I hope to see everybody next week.
All right. Thank you very much.
Thank you, guys.
Thank you very much.
Thanks, everyone.
How do I send you to the repo and the site?
Yeah, we can. You just communicate with me, and we'll share it on the platforms.
Cool.
Yes. All right, guys.